Hello and welcome to the walkthrough for my second Secure Code Review Challenge. My name is Florian Wolter, and in this video I would like to first go through the source code with you, just trying to get you a bit of an idea how to identify this vulnerability in the source code. Then I want to show you how to exploit it. And finally, I want to show you how to change the code to mitigate the vulnerability. So let's dive straight into the source code. So this is a Node.js app, or an Express.js app to be precise. So Express is the REST framework being used here. And you can see there are two main routes. There's the profile route, and then there's the fetch data route. So as you can see, profile is mostly mocked. So you can see here, this simulates profile data. So in the end, this request just logs something and then sends back that JSON to the user. So that doesn't look terribly interesting because the JSON itself is hard-coded. So there's no way for a malicious user or an attacker to mess with that. However, the second route is significantly more interesting because, as you can see here on line 20, it takes the URL from the query. So this means that this variable here, const URL, is directly attacker controlled, which means this is a very interesting point for us just to see how this URL is being used in the subsequent lines of code. So then we log something, and then if we look at this try catch block, we can see that Axios get is called with the URL. So this is interesting because Axios.get sends an HTTP GET request to the provided URL. And as we just said on line 20, the URL is attacker controlled, which means that an attacker can provide a URL and then an HTTP request will be triggered to the provided URL. So since your URL is attacker controlled, this makes line 24 vulnerable to server-side request forgery, SSRF. And there are two main types of SSRF. There is blind SSRF and then there is normal SSRF. And the main difference is that if as an attacker, we can see the HTTP response for the request, then it's normal SSRF. And if we can't see the response, then it would be blind SSRF. So what do we have here? Well, let's look at the next line. We can see that the response is sent back. So we can see rest sent, meaning it's getting sent back to the user, with the response.data, meaning this here is the HTTP response body of that request. So that means we have a normal SSRF here, where an attacker can provide the URL to be requested and then can see the HTTP response body. So this often constitutes a critical vulnerability because it may allow an attacker to access internal resources. And the most common, or the easiest exploitation these days, is accessing the metadata service, for example, of an EC2 instance. So say this Express app would run on an EC2 instance, then we can access the metadata service via this SSRF vulnerability, which would allow us AWS credentials into the target instance where this app is running, meaning we could then use that to further escalate into the infrastructure, into the AWS infrastructure of that vendor, of that application. Okay, enough about the code for now. Let's have a look at the running application. So I'm running this locally using the provided Docker Compose YAML file. And here is the profile endpoint, right? The one that we saw before, which just sends back this hard-coded JSON. So again, that's all hard-coded. An attacker can't control any part of that request. So it's not terribly interesting for us. However, the other request, the fetch data request, allows us to provide this URL here, right? Rec query URL is this URL parameter in the query string. And if we, for example, pass in https://google.com, then we can see here that Google is actually rendered on localhost 3000. So what's being sent back to us here is the response body, as we can see on line 25, right? So we can trigger a request to any URL and then see the response. And I said the next step would be trying to find out a little bit more about this application. Like, does it run in AWS? Does it run in Azure? Is it maybe on an EC2 instance, right? And based on the knowledge we enumerate, we're trying to access as particularly interesting internal resources and try to, for example, find credentials for further exploitation. Now let's talk about how to remediate this vulnerability. So say we are an application security consultant and we're talking to the development team of this app. The first thing we want to do here is clarify if the whole URL actually needs to be controlled by the user. So that's the first thing I would ask. Do we actually need the user to provide the whole URL to fetch data from? Or is it only like 2 or 3 internal web services that you want to fetch data from? Say it was the case that they only have this one internal app, then the easiest way to mitigate this vulnerability is by only allowing the user to control the URL path, say, for example. And we could also validate that this was alphanumeric and ultimately hard code the host of the app. Okay, so how do we do this? So first of all, let's add some validation in. So say from now on, we don't want the user to provide the whole URL anymore. So let's do it something like this. So let's get an actual variable for the full URL, which goes to internal app, which is our internal web services where we want to fetch data from. And then we only allow the user or the attacker to control URL param. So they can't control the actual host anymore. So they can't talk to the metadata service anymore, for example, but they can only talk to parts of this internal app now, which is what we want as the developer, right? So there's different routes to fetch data from this internal app. And this is the only thing we want a user or an attacker to be able to call here. So next we want to provide some validation here. So this will be from now on called URL param because it's not the full URL anymore. And now we add some alphanumeric validation here. So that looks much better. So what's going on there now? So we still take the URL from the request. I mean, we could rename it now because it's not the full URL anymore, but let's just leave it that way for now. And then URL param is checked to be alphanumeric, meaning only numbers and letters. And if it is the case, or if it is not the case, we send back a 400 error, right? But if it is the case, then we concatenate it into this full URL, which is then used for the HTTP request below. On top of this, we could also URL encode this, but since we already validated it's alphanumeric, this would be probably a bit of an overkill. It wouldn't do anything, it would just be a defense in depth, so to speak. Right, so the last thing I want to do is I want to show you the new app with that changed code. So what I'm going to do now is I'm going to pause the recording real quick and I'm going to redeploy this application using Docker Compose. Okay, and we're back. So now we are looking at the new app here. So the profile route hasn't changed, right? It's still the same, but the fetch data, if we now doing the same, trying to request google.com, we get an error, invalid URL. Only alphanumeric characters are allowed, which is that what we have here, right? So that means it's working. So that's looking pretty good. So now the only thing we can provide is something like this, right? Oh, that's not good. So I did some quick debugging and decided to actually leave this in the video, because why not? And what we can see here, so this is the logs from this Docker Compose instance. And we can see here error fetching data from URL and reference error URL is not defined, which makes sense, right? Because this variable const URL doesn't exist anymore. But now what we have is full URL, right? Okay, so I redeployed the Docker image and now let's try this again. And okay, we still get an error fetching data, right? Which is because this internal app here, it simply doesn't exist. I just made it up. I don't have anything running on my machine right now that is called internal app. But yeah, we can see everything's working in this application now after hard coding the host and only having the actual URL path being attacker controlled. And on top of the validating that this URL path is alphanumeric, doing these two things, we successfully mitigated the risk here and dealt with this server-side request forgery vulnerability. Yeah, that's all I got for today, I think. So thanks for watching this second video, the walkthrough for my second Secure Code Review Challenge. If you have any feedback for me, anything you feel like I could be doing better, or anything about the video itself that could be improved, yeah, just let me know, please. This is my second video ever, so I'm sure there's a lot of room for improvement. Yeah, just put it in the YouTube comments or reach out to me on LinkedIn. Thanks. Bye bye.